Good day. Today, I will be giving a summary for Chapter 5, Linear Programming. What is linear programming? Linear programming is a mathematical concept that is used to find the optimal solution of the linear function. Real-life applications of linear programming include engineering, manufacturing, agriculture, and many more other applications. The sub-lessons of linear programming are linear inequalities and the systems of linear inequalities. Linear inequalities. These are expressions wherein two values are compared by various inequality symbols. For example, 3 is greater than 1, 6 is less than 19, 3x is less than 7y plus 4. Graphing linear inequalities. So, for number 1, we have here an example of an equality, which is x is less than or equal to negative 2. So to graph this inequality, we should first look at the variable, the given variable, which is x. And x is horizontal, therefore we will count negative 2 horizontally. So in this case, it's negative 1, negative 2. And since this is a less than or equal to, we will be drawing a straight and solid line. And since it is less than, and less than is towards the negative, therefore we will draw arrows towards the negative side. And that is how you graph number 1. Let's go to number 2. For this case, it's y is greater than negative 6. So, since y is vertical, it means that we will count negative 6 vertically. So, in this case, it's 1, 2, 3, 4, 5, 6. And since this sign is just greater than and not greater than or equal to, therefore, we should draw a broken line. And since this is greater than, and greater than is towards the positive side, therefore we will draw arrows towards the positive side. And that is how you graph this inequality. Systems of linear inequalities. This is just basically multiple linear inequalities at once. This is the example. Example problem for system of linear inequalities. So, for the given and the question and the given is maximize the profit function z equals 50x plus 18y, and the constraints are 2x plus y is less than or equal to 100, x plus y is less than or equal to 80, x is greater than or equal to 0, and y is greater than or equal to 0. So the first step is to write their inequalities and find their corresponding equations. And the next step is to find the coordinates of x-intercept and coordinates of y-intercept of these corresponding equations. So in this case, in order for us to get the x-intercept for 2x plus y equals 100, we will just be simply substituting y equals 0. So this will become 50 and 0. Oops. And for the y-intercept, we will just simply be substituting x equals 0 into this equation. So it will become 0, 100. And same goes for this second equation. Now, after determining the x and the y-intercept of these corresponding equations, we are now ready to graph these equations. So, for 2x plus y equals 100, the x-intercept is 50, so this is 50, and the y-intercept is 100. And we are to draw a line from 100 to 50. And for x plus y equals 80, this is 80, x equals 80, and y equals 80. And we are to draw again a line from 80 to 80. So, the next step is to determine the optimal solution. To determine the optimal solution, we must first determine the feasible region. And the feasible region is determined by all constraints. So in this case, the points of the feasible region is as follows. This is the first one, this is the second one, this is the third one, and this is the fourth one. Now, the region within these four corner points are your feasible region. It's called your feasible region rather. After determining the feasible region, we are now to plug in the coordinates of the 4 points in this equation. So in this case, if you will plug in these 4 corner points into this equation, it will become like this. And since point C has the highest value, therefore it will be considered as the optimal solution. Equals point C.